Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss the upcoming videos, subscribe to the channel and turn on the notification bell to receive all updates. Imagine looking at the night sky. Among the sparkling stars, there is a black, motionless, silent space. Empty, you'd think. But what if you were told that this darkness is actually more full of activity than the beating heart of a galaxy? That what we call nothing is one of the most turbulent and mysterious places in the universe. Have you ever thought that the vacuum is not really empty? That what we call nothingness is actually a bubbling sea of invisible activity, a sort of cosmic theater where an endless play is being performed, without an audience and without a curtain. What we call vacuum might be the greatest illusion of the universe, a deceptive concept hiding a reality far more complex, vibrant, and active than one could imagine. It's not a silent space between stars or a simple void like in a deflated balloon, but a dynamic entity, a deep structure of the universe that contains within itself the potential of the entire reality. When we talk about the quantum vacuum, we enter a territory where common logic dissolves and the laws of classical physics no longer apply, giving way to an incessant dance of virtual particles, energy fields, spontaneous fluctuations, and mysterious interactions. For centuries, the vacuum was understood as the total absence of matter, energy, light, sound. The ancients considered it a paradoxical concept, difficult to accept even philosophically. Aristotle denied it, while Eastern thinkers attributed mystical meaning to it. Even modern scientists, up to the early 20th century, imagined space as a vast black box, dark, silent, an inert container in which planets, stars, and galaxies flowed. But with the advent of quantum mechanics, everything changed. The pioneers of this new worldview, including Planck, Heisenberg, Dirac, showed that reality on a microscopic scale follows completely different rules than those we observe in our daily experience. One of the most disconcerting aspects concerns the vacuum itself. According to quantum physics, even when we remove all matter from a space, what remains is not nothing, but something. That something is a continuous whirl of latent energy, a field of possibilities, a constant ferment where nothing is ever truly static. The quantum vacuum teems with fluctuations. Pairs of particles and antiparticles appear and disappear in extremely short times, in only apparent violation of conservation laws, as they fall within the limits imposed by Heisenberg's uncertainty principle. It's as if the universe itself is playing dice, generating tiny entities and then erasing them an instant later. And this does not happen in exotic laboratories or artificial conditions. It happens everywhere, all the time, even between the most distant galaxies, even in the space that appears most empty. A concrete and surprising example of these fluctuations is the Casimir effect. Two metal plates placed very close to each other in an airless environment are pushed towards each other by a pressure generated by the difference in energy density between the inside and the outside of the plates. It's one of the most elegant and direct proofs that the vacuum is actually an active and influential system. The implications of this discovery are profound. Not only is the vacuum not absence, but it could be at the root of some of the greatest and most mysterious phenomena in the universe. Vacuum energy, also called zero-point energy, is today one of the leading candidates to explain the accelerated expansion of the universe. It is thought that this mysterious force, called dark energy, represents about 70% of the universe's total energy content. It is an energy that acts repulsively, pushing galaxies away from each other at increasing speeds. But how can a vacuum push? How can nothing exert a force? It's a question that touches the very limits of our understanding of reality. Astronomical observations, especially those related to the cosmic microwave background and the distribution of galaxies, clearly indicate that the universe is expanding faster and faster. Something, therefore, is blowing it up from the inside. And the increasingly well-founded suspicion is that this something is precisely vacuum energy. However, this brings us to one of the most embarrassing problems of modern physics, the cosmological constant problem. When theoretical physicists try to calculate how much energy the vacuum should contain, they obtain a result so huge, dozens of orders of magnitude greater than observations, that it seems almost absurd. It's the largest discrepancy ever recorded between theory and experiment. A discrepancy that has led many to reconsider the very foundations of our model of the universe. There may be something we're missing, an as yet unknown mechanism that regulates the energy balance of the vacuum. And this leads us to another fascinating theory, cosmic inflation. According to this model, in the very first moments after the Big Bang, the universe grew exponentially, going from subatomic to cosmic dimensions in a fraction of a second. Triggering this rapid expansion may have been vacuum energy itself. At that primordial moment, the vacuum energy density would have acted as an inflationary force, causing space itself to swell. It's an almost poetic vision. The universe, as we know it, may have been born from the vacuum, not as absence, but as an extreme fullness of possibilities. In this scenario, the vacuum is not only the foundation on which reality rests. It is the seed from which everything sprouted. Every galaxy, every star, every atom, every form of life may have originated from this invisible and bubbling substrate. And the surprises don't end there. Some scientists are studying how to harness zero-point energy to develop new technologies, especially in the field of space propulsion. Imagine spaceships powered not by conventional fuels, but by the latent energy of the vacuum itself. It's still science fiction, of course, but quantum mechanics also once seemed like science fiction. Today, it governs the technologies we use every day, from computers to lasers, from GPS to medical devices. And if the vacuum could one day become a source of renewable and inexhaustible energy, the very future of civilization could change radically. Moreover, there are even deeper questions. What happens to the vacuum near a black hole, where the curvature of space-time reaches extreme limits? How does the vacuum behave at the edges of the observable universe, where space and time blur? Is there a vacuum even more empty, a deeper level of reality, a sort of super vacuum from which even quantum fields emerge? Some theoretical physicists hypothesize that the quantum vacuum itself is not the final frontier, but just one of many layers of an even more complex universe, a kind of quantum foam from which space, time, and matter emerge. In this vision, the vacuum is source code, a cosmic language, a matrix from which all manifestations of reality arise. And perhaps the mystery of the vacuum is also a philosophical mystery. It forces us to rethink our way of understanding reality, matter, time, causality. It shows us that what appears to be nothing could be everything, that the silence of the universe hides a secret symphony, that the darkness between the stars is a theater in turmoil. Understanding the quantum vacuum, therefore, doesn't just mean advancing science, but also getting closer to a broader, almost spiritual truth about our place in the universe. In the end, what we call vacuum might be the fullest reality that exists, a source of energy, structure, information, and mystery. An invisible ocean in which all the laws of the universe swim, a silent womb from which everything that exists was born. And every step we take in understanding it reminds us that the true essence of the cosmos may be hidden precisely where we thought there was nothing.